Okay, so here we're going to start with applications of quadratic functions. So they're going to be word problems where we're going to solve it using the properties of the graph of the quadratic function. You know, the quadratic function, it's a parabola, it's up and up or up and down. And what you're going to use actually is that the parabola, if it's up and up like this, the vertex is the minimum point. And if it's up and down like this, the vertex is going to be the maximum point. That's pretty much most of the applications about. Also, we're going to talk about x-intercepts and y-intercepts in terms of reaching the ground, okay? So we're going to have application where you're going to have object is launched and thrown down or up, and when it's going to reach the ground and how long it's going to be in the air and stuff like that. So let's start with this prep for the application where we're just going to analyze the problems, the word problems. So here we have in number 1, object is launched directly upward at 19.6 meters per second. So that's the speed, right? From 58.8 meter tall platform. So this is where it starts, right? The function for the object's distance from the ground at time t seconds after launch is, this is the function, and d is in meters, and d is the distance from the ground. Okay, and we have when does the object strike the ground. So looking at this function, the distance function, the function have, it's a square, you have t squared, you have t, a number. So this is quadratic function. Looking at the number in front of the square, it's negative, right? So if you have negative number in front of the square, the parabola is going to be open up or down. Do you guys remember? If the number in front of the square it's negative, is it open up or down?
It opens down.
It's up and down. Good job. So you're going to have this case. This is the case we have given. The parabola is up and down, so it's going to be like that. And the question is when the object strike the ground. So let's answer all these questions and you're going to see. The speed of the object is measured in, what is the unit for the speed?
Meters.
Meters is distance. Meters per second is speed, okay? So the speed is how many meters per second. How tall is the platform? So the platform where it throws, how tall it is. It says here, from 58.8 meter tall platform, right? So the platform is tall 58.8 meters, okay? Write the function that models this problem. So where is the function? The function is d of t equals, this is the function, right? So that's the function we have. This is the function. And I'm going to rewrite it. Negative 4.9 t squared plus 19.6 t plus 58.8. Now in this function, quadratic function, the number in front of the square is going to tell me if the parabola is open up or down. The number by itself, c, is going to tell you where the initial point to throw the whatever it is, object. Here they're talking about object. You can throw a racket or ball or something. So object, this is the initial distance, the initial height, okay? Then the number in front of t represent what that represents. That's the speed, right? So the number in front of the T represents the speed of the object, and the number in front of the square technically is the acceleration, but this is in physics, so we're just not going to go there right now. Okay, what does D represent? D represent what? D is the distance, right? It says it here, object's distance from the ground. Distance from the ground, and is measured in what unit? Is in meters.
Meters.
Yes, good job. Everybody understand that? Okay, what is the question being asked? So what they're asking here? So they're not asking you actually to solve it, they're asking what is the question? Yes, what is it?
Asking, when does the object strike the ground?
That's right. They're asking when. So they're asking what for find the time, the distance, or the speed? What they're asking here? The time, right? They're asking for the time. Because they're asking when. When means the time. How many seconds after? When the object strikes the ground. Okay, everybody understand what you're asking? What they're asking? So that's the question. Okay, so let's think about if you have to solve it, what you need to do to solve this. If the object is in the ground, what is the distance? What is the distance with the ground? It's gonna be 0, right? So for this question, actually, they're asking what is the time? So find t. So when d of t, the function is equal to 0. Because they're asking the distance from the ground is 0. Because the function d tells me what is the distance from the ground, right? So when the distance from the ground is 0, that means the object is on the ground. Make sense? So they're asking for what t, the function or the distance with the ground is 0. Make sense? So mathematically, this is actually what they're asking. What is the time? So solve for t, find t, when the distance, when the function is equal to 0. So here, technically, they're asking you find the x-intercepts. So they're asking find the x-intercept. That's what you're gonna find on the, technically, mathematically, you need to find the x-intercept of the parabola. Make sense? Everybody understand that? So you have a function, and the question they're asking is find the time when the distance is equal to 0, when y is 0 technically, okay? When the function is 0 means when y is 0, and you have exactly this question on the test 1. So do you understand why asking that question is important? What is the difference between f of 0 and f of x equals 0? So that's exactly what you have here. Everybody understand that?
Yes, ma'am.
Okay. The next question is the same way. But here we have a ball thrown in the air. It's thrown from the ground. So that means in the function, you don't have the, so here instead of meter, you have height. So let's go over that real quick. It's the same type of question. Okay. So what you have? Okay, so we have a ball is thrown into the air. The height of the ball above the ground is represented by the function h of t, where we have the height is in feet and t is in seconds. So t is the time, h is the height, the distance, right? The speed of the object, what is going to be the speed? Can you tell me the speed, how you measure the speed?
Feet per second.
Good job, feet per second, good job. Now, what does the variable h represent? What is h? H is
Height.
height, that's right. Okay, that's the height. H is measured in what? What is the h? In feet, right? What is the t represent?
It represents the time.
Yes, the time, good job. And what is the unit they're using for the time?
Seconds.
Seconds, good job. And then the next question is sketch the path of the ball. X is the time and Y is the height. Is the graph a line or a parabola? So what do you think it is? Looking at the function here, this is the function given, h of t equals. This is the graph. You need to graph this. So what kind of graph is going to be? Line or parabola? Yes. Is it up and up or down?
Down.
Up and down, that's right. So if I want to sketch it, it's going to look something like this. Is it going to, where is going to start? So this is the time and this is the height. And it's going to be parabola up and down, right? So can you find the x-intercept and the y-intercept for this function? Looking at this. How you find the x-intercepts? You're solving the function equals 0, right? So you have to solve negative 16 t squared plus 8t equals 0. How are you solving this? You can factor out, you see both of those, they have t and t, right? So I'm going to pull out t, and I'm going to have negative 16t plus 8 equals 0. Everybody understand that? Yes or no? I'm getting 1t from each of the terms. I'm taking 1t from here and 1t from here, and that t is going to go in front. And then after that, I'm going to solve t equals 0. And when I solve this equals 0.
Professor,
Yes,
I have a question.
yes.
If you're taking a t from both sides, why would it only be one t if there's two?
Okay, so because when you pull out t, it's something like, see, if I distribute, this t is going to go for both of those. See, if I want to multiply, so this is, I'm going to write it here so I can see better. So if I have, I'm going to give you example with something x, just let's look x squared plus 2x, for example. See, this half x and this half x, right? So I'm going to pull out 1x, and I'm going to get x plus 2. Now, if I multiply, I have x times x, that gives me x squared, right? And then x times 2 is going to give me 2x. So you have it once because this in front of the parentheses means you have it for both of those. Make sense? You guys understand how I factor it out? So technically x squared means you have x times x plus 2x. This is what you have, 2 times x, right? So if I take 1x from here and 1x from here and I put it in front, and then in parentheses, I'm writing what is left. You got it? And then you can check it out. You multiply x times x, that's x squared. X times 2 is 2x. That's how you distribute. This is called distributive property. Did you guys understand this?
I have a question. How can you determine if if the graph is a line or a parabola just by
Oh, okay.
looking at it?
Yes, just looking at it, it's a parabola because you have square. If you have only t and number, then it's gonna be a linear function. It's gonna be a
Okay.
straight line. Yes?
Gotcha. So if it's squared, then it's a parabola.
Yes,
Okay, gotcha. Now that makes sense.
yes. Okay, so we solve t equals 0. That means the one of the x-intercept is gonna be at 0. And then when I solve the other one, negative 16t plus 8 equals 0, I can add 16 and t in both sides. And I'm gonna get 8 equals 16t. I'm gonna divide by 16, both sides. And that's gonna give me 1/2. Right? 1/2 or 0.5. So let's say this is 0.5 or 1/2. Okay, so these are the x-intercepts. So that means the parabola is gonna be up and down like this. So when you throw the ball, the object, a ball, actually they're throwing a ball. So this is the path of the ball. So you throw the ball from the original point from 0, 0. The ball go up, reach the high maximum point, and then go down again, right? Because of the gravitation, it's gonna pull it down. So this is what happened. The ball is going up, 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 and then it's going down. Everybody understand that? And then it's gonna, and this is how the graph is gonna look like. Everybody understanding this?
Yes, ma'am.
Okay, so that's how the graph is gonna look like. Okay, we're gonna do more of those questions. We're gonna throw some stuff in there. And of course, the gravitation is gonna bring it back to us, to the earth, to the ground. Okay, so number 3, let's look at number 3. Object is launched directly upward at 19.6 meters per second. This is the same question, right? Okay, it's the same question we just talked about, right? The same numbers. We have, but they're asking different questions here. They're asking, which unit should be used to answer? When does the object strike the ground? Okay, I told you some of the answers here. When? What unit you're gonna use here for when they ask you when?
Time.
Time. They're asking for the time, right? And what is the unit you're using for the time?
Meters per second.
Time.
Second.
Seconds. Okay. Now, meter per second is it's a speed. Okay. The next question, which unit should be used to answer what is the maximum height? What is the maximum height? So what is that? Height is measured in what?
Meters.
Meters, that's right. And it's also distance, right? I'm gonna put distance here. And the distance is measured in height, in meters. Okay. Which unit should be used to answer how long does it take the object to hit the ground? How long? What is that? What time? What kind of question is that? How long? What you
D of t
measure?
equals 0.
I'm sorry?
The d of t equals 0.
Yes, that's how you're gonna solve it. Yes, the d of t equals 0. That's how you're gonna find it. But what unit you're gonna use to answer that? After you solve it, what you're gonna get? What is the variable you're looking for?
Aren't you
Time
looking
in
for
seconds.
meters?
I'm sorry?
Aren't you looking for meters? Because it says where D is in meters.
D is in meters, but we're not looking for D here. We're solving the distance equals 0. So when you solve that, what you're gonna get? What variable you're gonna find? What letter you're gonna find? How long? What you measure with how long is gonna take you?
I'm in
do
seconds.
some time. It's a time. It's another question where they're asking you to find the time, right? Because when you solve the distance equals 0, you're technically finding t equals what, right? And that's the time, and the time is measured in seconds again. Okay, everybody understand that? So these are the type of questions you're going to be asked to find, and we're going to see how you're going to find them when you start actually solving the problems. Okay, here we're talking about what type of question is that. Okay, now the next question is about the second one. The second one, we talk about the ball thrown in the air. We have the same question, but they're asking different things here. They're asking which unit should be used, what is the maximum height? So what they're looking for, find what? You're looking for the height, right?
The-
We're looking for the height. So what is the unit for the height?
H.
H, that's H, but what is the unit? H is in what?
Feet.
Feet, good job. H is in feet, okay? Now, which unit should be used to answer when does it reach maximum height? When?
So that's going to be time, which is in minutes.
Yes, time. Good job. He's gonna ask you, they're asking you for the time, which means you're gonna use minutes here. Okay, good job. So everybody understand, you have to read the question carefully. You have to see what exactly what unit they're asking you to find, and what exactly is how you measure that units. Okay, what is the unit for that? Let's look at number 5. What if you forget to include units in your answer? Let's discuss that. So is it important to include the units in your answer? For example, you read a recipe that calls for 1/4 of peanut butter. How much peanut butter you're gonna use?
It's
1/4.
It's
Yes?
important because we need the measurements because we don't know if it's a cup, an ounce.
Yeah, we don't know what it is. Okay, kilogram, 1/4 of kilogram, 1/4 of cup, 1/4 of teaspoon, 1/4 of what, right? So this is very important, right? It's very important. So make sure when you solve word problem, make sure you always include the units. Always, okay? Everybody understand that? It's very important to include the units for your answer, okay? Let's see next one. Which word is more appropriate for each of the following scenarios, approximate or exact? Paying your CPS bill, is that approximate or exact?
Exact.
Exact.
Yeah, so you don't get a late fee.
Exactly. How about telling someone how many students attend Northwest Vista College? Telling someone.
Approximate.
Yes, you don't know exactly how many. You can just say like 15,000 or approximate. That's right. Because you're telling somebody, it's not something you have like have to present statistic about it or something. You just talking to somebody. Okay, writing 1/4 as 0.25. Is that the exact or approximate?
Exact.
That's exact, yes. Because when you divide 1 divided by 4 or 1/4 is exactly 0.25. Now, how about 1/3? Write it like 0.3.
Approximate because
That's a, Mhm.
divide it, it's gonna be a 0.3333.
That's right, because you round the number. Because
Mhm.
when you divide 1 by 3, it's going to be 0.333 repeating 3. That's right, good job. Giving the correct amount of medicine to a patient.
Exact.
Yeah,
Absolutely, have to be very exact. I mean,
Mhm.
absolutely perfectly correct, right? It's very important. Estimating your grocery bill as you stand in line at the checkout.
Approximate because estimating.
Yes, approximate because of the word estimating. Good job. Okay. So now here, the next one, we're going to use equal or approximately to compare the numbers given. So I'm just going to do a few of those. We're not going to do everything. But so everybody understand, if you round the number, then it's going to be approximately. If it's exactly that, then it's going to be equal, right? So for example, 0.5, is it the same like 1/2 or it's approximate?
Approximate. I mean, exact.
Exact. 1/2, it's exactly 0.5, right?
Mm-hmm.
Now, what is 1 divided by 7?
0.14285.
So it's continue, right? So it's not exactly 0.143. So we're going to put approximate symbol, right?
Mm-hmm.
1/3 the same way. It's approximate, 333 repeating 3. Okay, and so on. Now let's do 7/11. 7 divided by 11 is what? 0.636363 repeating, right? And this is exactly what they have here. So they don't round the number, but they put that 63, which means it's repeating. So you get the exact number there. Okay. How about 10%? Is it the same like 0.0993?
Approximately.
Approximate, that's right. 2/3, 2 divided by 3 is what? 0.666 repeating 6.
Approximate.
You actually round the number, that's right, 0.67. 5 divided by 6 is 0.83. So it's not 83%, it's also approximate here. Now 3 divided by 25, is it 12%?
Yes.
Exactly 12%, that's right. And the other one is 4.08%, obviously is not 0.04 because we round the number, the 8 is missing, right? Okay, so there you go. We actually did all of it. So that's how you know if it's approximate or exact. Okay. Now I need that because here we need to round numbers. Everybody know how to round, right? So I'm just going to do a few examples to round numbers. So let's do, so you know how to round, right? You have the decimal point here. This is the decimal point. And before the decimal, the units, units, 10, hundreds, thousands, 10,000, 100,000, millions, 10 millions, 100 millions, billions, and so on, right? And if you go after the decimal, it's going to be tenths, hundreds, and so on, right? So here you need to see where you're going to round to, and you're going to look at the next digit. Always look at the next digit. If it's 5 or bigger, you're going to add 1 to the digit you are rounding. And if it's 0 to 4, you just forget about the rest of the numbers, right? Now, if it's after the decimal, if it's before the decimal, you have to fill the empty place with zeros. So let me do a few examples so you see. Probably you're familiar with all this. So round to the nearest 100 place. So 100 place is, which number is in the 100 place?
5.
3,000, yes, 500. 5 is the 100 place, right? So you need to look at the number after 5. What is the number after 5? It's 8, so it's big. So you need to add 1 to the previous one. Add 1 to the 5. So you're gonna round this number like 3,006 and you fill out the rest of it with 0, 600. Everybody understand that?
Yeah, Professor.
Yes.
Is that supposed to be a decimal point? Because it's a comma.
No, it's a comma.
Oh, okay.
Yeah, it's a comma. So if it's a whole number, you round to nearest 100,000 and so on place. You're gonna fill out the empty places, the empty place value with 0. If it's after the decimal, you don't have to write them at all. Make sense? Okay, let's look at the next one. Round to the nearest unit. So unit is which number is in the unit place? The 5 again, right? This is where it says units. You see that units? Okay, so round to the nearest unit. So that means I have to stop at the decimal point. So what is the number after that? It's 2, small. So I'm not adding 1 to the 5. So you're gonna just forget about this after the decimal and it's gonna be 45. That's how you round it. Okay, any questions? Okay, let's do the next one. We need to round to the nearest 100. So where is the 100th place? Which number is in the 100th place? 100 with TH. So if it's with TH, that means it's after the decimal.
So the 8.
The 8. No, 8 is the 10th.
Oh yeah, the 2, right?
2 is the 100th place, yes.
Gotcha.
So 2, you're gonna look at 2. After 2 is 3. So just gonna forget about 3 and you're gonna round it like 39.82. Okay, everybody good with that?
Yes.
Okay, let's finish those. There are 2-3 questions left. Okay, so the next one you have round to 2 decimal places. So if they say it like this, that means after the decimal, 2 decimal places. So after that, the third one is 5. So I need to add 1 to the 8. So I'm gonna round it to 72.49. Okay.
Mm-hmm.
Now the next one is round 3 decimal places. So I'm gonna look here, the 3 decimal places, you're gonna be here. The next number is 8, so I'm gonna add 1 to the 3. So you're gonna round it to -3. Everything else stayed the same. 0.94. That's right. Okay. The next one you have to divide 2 divided by 7, and you have to round to the nearest 10th. 10th with H, so that means one number after the decimal, right? 10th is one number after the decimal. So when you divide 2 divided by 7, I have 0.2857 and so on, right?
Mm-hmm.
And you're gonna round to the nearest 10th. So I'm gonna round to here. After 2 is what? 8. So I need to add 1.
Yeah.
So it's gonna be 0.3.
Mm-hmm. Yeah.
Okay. The next one, it says around 2 decimal places. So the third decimal place is 8. So I'm gonna add 1 to the 9. So you're gonna round how? 0. What is 29 plus 1? 30, right? 0.30. Okay. And then the next one, I'm going to divide these 2 numbers to see what I'm going to get. And you need 2 decimal places. So I have 149. I'm going to divide it by 251. And that's 0.5936. 2 decimal places. So I have enough. 2 decimal places, so it's going to be over here. The number after that is 3, so I'm just going to cut those, and it's going to give me 0.59. Okay? So that's how you round numbers. Everybody understand that?
Mhm.
Okay, always look at the next digit. Okay, the next one we're talking about, we're going to go over its applications on quadratic functions. So here we're going to start actually preparing to solve application problems, word problems. So we have the goal for the next section is to solve word problems involving quadratic functions. Suppose the graph below represents the path of a ball that has been thrown into the air. Label the following on the graph below. So we have the graph given. We have to draw a star over the point on the graph that represents where the ball hit the ground. So this is the graph where the ball is going to hit the ground. It's going to be right here, right? That's why you're going to put the star. Yes? Everybody see that? The next one, we have to draw a triangle over the point on the graph where the ball reaches the highest point. And that's going to be the vertex, right? So this is where the vertex is going to be. That's where you're going to put your triangle. And then we have to draw a circle over the point on the graph where the ball was first thrown. So where the ball started paths over here on the y-intercept, right? So let's talk about in math. The star represents the x-intercept, right? On the graph. The triangle represents the vertex on the graph, right?
Mhm.
And the circle represents the y-intercept on the graph. Okay? So
Mhm.
always keep that in mind. Whatever the point was first thrown, that's the y-intercept. That's the point where the ball starts its path. The maximum is the vertex, and the x-intercept is when the ball hit the ground. You're going to look for the x-intercept. Everybody understand that? Okay, then we have another one like that. Something like that. We have a graph. Suppose the graph below represents the path of toy rocket that has been launched into the air. If the x-axis measure in time, so the x-axis is the time, and the y-axis is the height, we need to answer those questions. So this is the height, and this is the time. And the questions are, why does the graph only show the portion of the parabola in first quadrant? Why you think that? See, there's no graph in the below
That's
the
where-
x-axis. I'm sorry?
That's where it was thrown.
Because it's shown from here, okay? But why they don't show before that? They have a little dot, which means it's not shown. And why the graph doesn't continue here? See, it's not continued down here.
Can't
Why
go
is
in the
that?
ground.
I'm sorry?
It would be in the ground.
It have to be in the ground because it's a word problem, and because all the measurements here have to be positive because the height is a bit bigger, because the height have to be bigger than 0. Okay, the height cannot go below the x-axis, and the time also has to be bigger than 0, and that's exactly first quadrant. First quadrant is where x is positive and y is positive, right? Because we're dealing with a word problem. So the height is not negative, it's not going below the ground, and the time is not going back in time, right? So start from 0 and go forward. Make sense? So why do we ignore 1 on the x-intercept on the graph? So why you ignore this x-intercept here? Again, the same reason, because that's before the ball was thrown, right? So it's outside of the range and the domain of the function. Make sense? Everybody understand that? Okay, so the next one is actually solving some applications. 115 to 118 is the one we're going to solve applications. There are a few people coming again right now. Yeah, I'm going to do those. I'm going to solve a few of those. And then we're going to put you in group to work in your homework. Okay, so let's go over this number, page 115. So these are applications. To solve the word problems involving quadratic functions, we're going to look for the keywords or phrases that relate to some parts of the graphs. Okay, so we're going to consider a quadratic function that represents the object being shown. So we have to label the y-intercept on the graph. So where's the y-intercept on the graph? I have three different things here. Okay, so the y-intercept is going to be over here, right? In this case is 0, 0. That's the y-intercept.
Mm-hmm.
Now, what the y-intercept represents?
Y-intercept could represent height. It could represent.
Yes. The y represent is the starting point for the ball or for the object. So
Right.
this is the starting point. That's where the ball is thrown. It could be thrown from the ground. It could be thrown from the different height, right? So that's the starting point. And also the y-intercept is when the time is 0. So keep that in mind. Starting point of the object and when the time is 0. Okay? Method to find the y-intercept. How you find y-intercept? If you have equation, how you find the y-intercept?
You solve for x and then plug it in and then solve for y, right?
You don't solve for x, you substitute x with 0. So
Yeah,
in this
that's what I
case,
meant.
yes. You plug it in or substitute. T equals 0 and it's going to give you the y-intercept. Make sense? I'm going to use t technically is x equals 0, but most of the problems we're going to solve, the x-axis is technically the time. So we're substituting t is equal 0 and that's how you find it. Okay? And then simplify. We're not solving, we're simplifying equation, right? Function notation for the y-intercept. What is the function notation? It's going to be f of t equals 0. That's how you write it. I'm sorry, f of 0. You substitute 0. F of 0 equals. Okay, you substitute f of 0. Okay, everybody understand how to do the y-intercept? You plug it in 0 for x, for t. Okay, the next one, let's label the x-intercept on the graph. So they're going to be two x-intercept, right? One is the starting point and the other one is when the ball or the object hit the ground. And again, t is the time. What the x-intercept means, what is that?
The ending point?
I'm sorry?
Is it the ending point?
The ending point, that's right, or yes, ending point. And it's also when the object hit the ground. Usually that's what they're asking.
Mm-hmm.
That's right. How you find the x-intercepts? Here, how you find the x-intercept? You substitute y0, which means you solve high or solve y equals 0 or the equation equals 0. You solve it. Here we're solving. Okay. Functional notation, you're solving f of t equals 0. Okay,
Mhm.
everybody good? Now the next one is labeled let's talk about the vertex. So these are the things you're gonna solve actually for. You're gonna solve for x-intercept, y-intercept, and vertex. So what is the vertex? The vertex is the maximum point, right? So this is the vertex over here. Again, you have the time. What are the word that means to x coordinate of the vertex? So the vertex has x and y coordinates, right? So the x coordinate always represent the time, and the y coordinate represent the height. And I'm gonna put height or distance, doesn't matter, height. And the y is the time. Okay. So now, what word you using to find the x coordinate? What is the word? Let me go here and find it. If you have it. So let me know. Think about it. Think about it. When they're asking you to find the first coordinate on the vertex, what they're gonna ask you to do? They're gonna ask you to find when the ball or the object is gonna get the maximum point, right? It's gonna reach the maximum point. So the question is gonna be when the object will reach the maximum. So vertex is always related to the maximum, but they're gonna be asking you two things. They're gonna ask you when, and the y coordinate is what is the maximum?
Professor,
Yes.
couldn't they also word it like what's the highest point on the graph?
Yes, what's the high points and the graph is gonna be b, the y coordinate. What is the maximum or what is the highest point? Yes. That's right. So when they're asking you what is the highest point, what is the maximum on the graph, when it's gonna reach the highest, the maximum point, then they're gonna ask you for the y coordinate of the vertex. And when they're asking when, which is related to the time, is gonna be when the object is gonna reach the maximum or the highest point. Make sense? Now, what is the method to find the vertex? How you find the vertex? Use the vertex formula, right? What was the vertex formula?
Isn't it k equals h divided by 2 times,
H
I forgot.
equals negative b over 2a. That's the
Why'd you
formula.
let me go on so long if I got it wrong?
Okay. So the formula is h equals negative b over 2a. That's the h. And k is f of h. Okay. So this is how you find the x coordinate and the y coordinate for the vertex. Functional notation for the vertex is pretty much this is the functional notation of the vertex. Okay. Everybody understand that? Any questions here? Okay, so now we're gonna actually start solving a problem. Okay, so far we're just talking about it. Now we're gonna solve a problem. So the question is, answer the following question. We have a graph given, which is the height in feet. of a small rocket t seconds after its launch, right? The path is given by this function. They give me the equation of the function. And the question, we have the graph also. So the question is, how long is the rocket in the air? How you know that? You're gonna look at the time, right? How long is in the air? Can you tell me?
8 seconds.
8 seconds, good job. It's from starting from here and ending here. That's 8 seconds. Everybody see that? Okay, what is the maximum height of the rocket? We're gonna come here, the maximum, and it's gonna be between, let's see at the graph.
Is it like 255 or something?
2, 10, 30, 40, 50. Yes, 255. It's about 255 feet. Make sure you put the units. Now, how you can find it? Can you find it? Using the equation? Yes, you can use the equation to find it. How are you going to do that? We're going to use A and B, and you're going to use the vertex formula. So let's check that if it's 255. It could be 254, and you can see the difference, right? The graph, the scale is not too precise. So let's see. Using the vertex formula, A is going to be -16, and B is 128, right? And C is 0, we don't need that. So we have H is, so the time when it's reached the ground is going to be when? Not the ground, the height is 4 seconds, right? So H is going to be 4. And then when I replace, actually, I don't need to use A and B. It's obviously from the graph, it's 4. So H is 4. And when I plug it in 4 into the function, so it's going to be what is, I'm just going to plug it in. So it's going to be -16 times 4 squared plus 128 times 4. So we have 16 times 16 is is -256 plus 128 times 4 is 512. So it's actually 256. So everybody see that? So the height is not 255, it's 256. Okay? So if they give you the equation, not only the graph, you can calculate using the equation 256 feet.
Gotcha.
Got it? Okay. What is the height of the rocket 2 seconds after its launch? So let's see. 2 seconds after its launch, it's, oops. Okay, so it's going to be over here, right? And it looks like it's about 190, but the best way to do it is just follow the equation and replace T with 2. So it's going to be H of 2 is going to be negative. That's the exact. So it's -16, 2 squared is 4. I'm just going to put 4 plus 128 times 2. And when I do that, 128 times 2 is 256, and I'm going to subtract 16 times 4 is 64. It's going to be 192. See, it's exactly, it's not 190, it's 192. So looking at the graph all the time is not exact, it's approximate. Make sense? So 192 is going to be after 2 seconds. Okay. Is the rocket going up or down 2 seconds after its launch? Obviously, it's going up, right? Yes, it's going up. Why it's going up? Because it's still before the maximum, right? So it's going up. The next question, what is the height of the rocket 6 seconds after its launch? So that's what you're going to do now. We're going to replace t with 6, and you're going to calculate that. So I have negative 16. I'm going to write it here. 6 times 6 is 36 plus 128 times 6. And you're going to calculate that. So we have 16 times 36 is negative 576 plus 128 times 6 is 768. And that gives me 576, 192 again. Everybody see that? So 2 seconds after its launch and 6 seconds after, the rocket is going to have the same height. Why is like that? Because those 2 points are symmetrical. So you look at the parabola. See the two seconds after and 6 seconds after, they're in the same height. Okay? And these 2 points are symmetrical across the axis. This is the axis of symmetry. Remember, we talked about that last time. Axis of symmetry is the line going through the vertex. So they're going to have the same height. Make sense? Everybody see that? Now, the next question is the rocket going up or down 6 seconds after its launch?
Down.
That's right, it's going down. Okay, when is the rocket 112 feet height? We have to estimate, so it's not exact. So 112 feet height, we're gonna technically solve f of t. I'm sorry, not f, it's h. The function is h, not f. H of t equals 112. So if I want to solve precise after how many seconds is going to be at height 112, I have to solve the function equals 112. Okay, but they want me to estimate. So if they want me to estimate, I'm just going to look at the graph. Let me write it better. H of t equals 112. And I need to solve it, right? To find exact. Now, if I need to estimate, let me see, let's look at the graph. 112, 110. So 110 is here. This is 120. So it's about
1.1 second.
1 point something, yes. Somewhere here, right? And also, there are going to be 2 places. So let's say about 1 and 7 seconds, right? Yes? Everybody see that? So if they want me approximate, if they want me to get the approximate time when it's gonna be at height 112, I'm gonna say 1 and 7 seconds. That's the estimate. 1 second and 7 seconds. It's gonna be in that height for 2 different seconds. Now here I forget to put the feet, right? You see that? Don't forget the units, okay? Now the next question, do you think that the rocket is traveling faster from 0 to 1 or from 3 to 4 seconds? What do you think?
I think it's equal, like it's equivalent.
I think 0
1
to
to
1.
4, I'm sorry?
0 to 1 is faster.
Faster, okay? How you get that?
It's more distance traveled in that time.
Okay. The distance travel. So what you using to do that? Distance travel.
And the graph, it looks like it's traveling like more distance.
On the graph, 0 to 1.
Mhm.
Let's look at that. 0 to 1 and 3 to 4. 0 to 1 and 3 to 4. So we're talking about 0 to 1 is here and 3 to 4. Yes, good job. That's right. So at 0 to 1 is traveling faster, right? And that's a very good explanation that the distance is longer from 0 to 1. Okay, good job, guys. That's right. So everybody understand that? So the answer here is going to be from 0 to 1 is faster. Okay. The next question, write a reasonable domain and range for this event. So what is the domain? Domain is X, right? Or T in this case. So what is the domain? Let's look at the graph. Domain is from what? From 0 to what? So this is the domain.
0 to 8.
That's right.
Mhm.
And the feet is the range. This is the range.
So 0 to 8 seconds.
That's right. So the domain is gonna be always X coordinate is domain, Y coordinate is the range. Keep that in mind. So the domain is gonna be from 0 to 8 seconds. That's right. And actually you're gonna use brackets because internotation. So it's gonna be from 0 seconds to 8 seconds because you include that. And what is the range? From 0 feet to what?
55.
0 to
What was the maximum height?
250.
256.
Yeah, 256 because of the vertex.
Yes, we calculated this 256. And you're using brackets in this interval notation because we're including the 0 and including the 256. Okay. Okay, everybody understand that? Okay, so all these questions, that's how you're gonna solve them. Okay. Now I'm gonna put you in groups to solve some more applications, and they're pretty much the same questions. Okay. And then you're gonna discuss it.